Please welcome our panel, Convergence of MLOps and Data Pipelines, with 𝗁𝗲𝗿𝗄 from Capital One, 𝘁𝗲𝗿𝗄𝗆 from DoorDash, 𝗁𝗲𝗄𝗆 from Overstock, and moderated by 𝘁𝗲𝗿𝗄𝘆𝘀 from Microsoft.
Hello, everybody. Good morning, good evening, wherever you're tuning in from. We have great panelists here talking about the convergence of data and MLOps. So the first question for the panelist, when you think about the build versus buy decisions for your platform, for your ML ecosystem management, can you please talk a little bit more about how do you think about it? Anybody can pick it up. Alok, do you want to get started first?
Sure. Yeah, happy to talk about that. I think for a new area we're discovering, we're very much keen on working with a partner, a vendor to test and pilot whether this is really going to solve our problem. I think what happens over the long term once a vendor and platform proves valuable is we look for maybe more customizations or maybe to unlock more value or cost savings. And that's when we start to think about, does it make more sense to bring this in-house to our specificities or continue the relationship? I think a lot depends on the vendor's future roadmap as well, and whether our desires and what they're working on, they overlap.
Thank you. Vidhu?
Yeah, I agree with what Alok said. I think build versus buy is an important consideration, especially for an organization in the early stages of adopting ML within the enterprise. I've seen companies pursue a buy option to kick off the ML practice and build momentum, and then bring it back in-house as they scale up. I've also seen companies which have cobbled together their own ML platform. This was in the early days of ML when there weren't good alternatives out there, and then replace parts of their components, parts of their platform with off-the-shelf components. My recommendation would be for an early stage adopter to consider an out-of-box, end-to-end, possibly hosted ML solution. This will give you an opportunity to better understand workflows that your ML scientists prefer.
Great. Thank you. And Abhijit?
At our scale, we believe that in the marketplace, the right solution for the capability or problem we are building at hand should always win out, regardless of whether we build it or buy it. So instead of considering a build versus buy, what we have tried to do is to just focus on a few best practices and principles. For example, we have a common platform foundation that can take either, and everything is on public cloud, but a common platform foundation that can take any third party, kind of capability as an operator, and also, our homegrown kind of, components. Same way, our data science and modeling pipelines are pretty much like standard between development and deployment, like in serving infrastructure. So standardization, common platform foundations, converging the CI/CD stack on both sides, like development and deployment, basically help us to kind of ingest any kind of components, whether it's built by us, whether it's built in open source, or whether it's from a third-party hosted solution on public cloud.
Got it. So hearing from you all, it looks like now you want to consider the complexity around selecting the tool sets. What is the expertise that you have, and try to have a cohesive strategy, right? That's what I'm hearing. That is common across all when you consider build versus buy. That's fantastic. On that note, there are multiple options available. You could organically build or expand or whatnot, but it also means, do you have a centralized ML platform or MLOps platform, if you want to call that, or do you have a bunch of tools that are working together, or you are orchestrating them, or you made them all work together? In no particular order. Whoever wants to go first, please go ahead. The question is is it like a one end-to-end ML platform, or is it a collection of tools or collection of homegrown tools, or open source tools that you're stitching together?
I can take that. For Capital One, our strategy is that we're going to have some central MLOps platforms and capabilities. But within that, there are options and ways to extend the things that we are building by other teams. So, we have central ways to build a model, train a model, access all of our data on the cloud, feature engineering, and then, really a very sophisticated automated way to take that model and deploy that in production through all of the governance, checks that we need to do, being a regulated financial company. But within that, people can have lots of options, and they're constantly actually innovating on, different training stacks, different ways to, validate their model. We even look at a lot of the work that, different teams are doing, and then kind of finding a common pattern, and then building a library, and then scaling it out through the platform for all of our other users. So we have taken that approach, like central platform, but with a lot of flexibility to extend them, by our end users.
Got it. Thank you. It's like a mini as a service platform, but that is, you're building it. A centralized team is taking care of that.
We are very inspired by a lot of the cloud platform providers. It's truly a multi-tenant SaaS platform that we have built, taking the best of cloud providers as well as open source components.
Thank you. Other panelists?
Yeah, I think DoorDash has a very similar strategy. We have a centralized platform that sort of serves 90% of our ML use cases at the company, and there are edge cases that maybe can't fit in that. But I think we'd push a bit further and say we think it's a strategic advantage for us to have a lot of our ML features, models, training pipelines centralized, because we can use them in multiple places. If there's useful features for ranking or recommendations or personalization or forecasting, we can use them in different contexts, on the merchant app or on the consumer app, etc. So for us, it's really been about creating leverage that we've had a lot of this centralized.
Yeah, Overstock is very similar as well. We have a centralized ML DataOps platform team. The reasoning is having a centralized team gives us an opportunity to establish some of these best practices, standardize technologies, and really codify all these things, practices into a central platform. Our ML group, the ML scientists, are also in a central team. The reasoning is pretty similar. We kind of want to have our ML scientists share best practices, collaborate much more closely. I do believe in ML scientists aligning themselves closely with the business counterparts that they're working with to better understand their existing workflows and identities.
Got it. Thank you. Even though, we can talk a lot more about, I would like to talk a little bit more about how you're handling the data pipeline itself, but I'm just curious about your tech stack. Looks like you all have built your own centralized ML platform. The reason why I'm curious is not only building the data science part is hard, you also have the platform side of it that enables the data science, right? Can you talk a little bit more about your challenges? Talk about the tech stack that you have using or you have used to build your centralized ML platform, and some of the challenges that you faced on the way.
I can talk about the Capital One approach. We decided early on that we are gonna have a common platform foundation in terms of like the control plane will be Kubernetes based. And to give you an example of how we decide build versus buy, in the early days, we actually took enterprise like 𝗁𝗏𝗄s, which is a way to kind of open source way to control a Kubernetes, infrastructure cluster. We actually built like a homegrown version of 𝗁𝗏𝗄s that are compliant as a banking grade kind of like a compliant software. But now, as we move towards more hosted solutions like EKS and GKE, etc., like we are actually going to move into that direction. But that's like a good build versus buy, kind of a trade-off. Like early on, you start something, but then as a more mature solution comes, you adopt that. In terms of our data pipelines, we have been investing in AWS, almost like 4 or 5 years now. We have built a lot of central streaming platforms, central registration of all of our data. Again, like a lot of capabilities already exist within the company to do lineage, a lot of like on-demand kind of a feature calculations. In terms of model training, we use the 𝘀𝗲𝗄 pipelines, which is again, originally from Google, but now it's widely available. And we even have gone above and beyond K pipeline. We have actually created a marketplace of all of the different K pipelines that our users, have built and contributed. So these days, if you have to do any kind of sophisticated model training, you don't have to start like from scratch. Like there is already a marketplace of all kinds of pipeline and workflows that our data scientists can start with.
Thank you, Abhijit. Alok, do you want to go next?
One anecdote I'll add is maybe at the start of our journey, which might be interesting for listeners. We made a choice to start with as few ML packages as we could to enable our ML scientists. So, for example, we knew we needed to enable deep learning for our ML scientists, and we knew we wanted to enable tree-based methods. So we actually did a bake-off between TensorFlow and PyTorch for deep learning and XGBoost and LightGBM for tree-based methods. And we've written this up as a blog post on the DoorDash engineering blog. But we tried a few different models, a few different objective functions on each of those platforms and saw what was better from a user experience, faster, cheaper, had more tunable, customizable parts to the library, and then based on that picked one of each, and that served us well for a couple of years. And then more recently we've started to think about containerizing and allowing more speciality packages onto the platform. But I think that's a place where you can spend a bit of time in your decision making and move quickly to unblock yourself by limiting the choice set a little bit.
Awesome. Vidhu?
Yeah, Overstock, interestingly, we have a centralized ML platform team. Our platform itself is composed of different components from different open source solutions. For example, our feature store is Feast. We recently adopted Feast. We are in the process of vetting it and actually rolling it out more broadly. We use Spark, Dataflow for doing the transformations. We run our transformation workloads in the cloud. We also run it on-prem. Some of them is run on-prem. We use Cloudera's data platform to do some of the transformations. Our ML scientists rely heavily on notebooks for data exploration. We rely on BigQuery again in Google as our central data warehouse. So it's a bunch of different things, and that's one of the charters of the team is to kind of unify this and standardize the process so we have one single platform.
Awesome. So looks like you built a great platform. So everything looks easy peasy, right? There are no challenges at all, right? I'm just kidding. So when you that's a nice segue into some of the challenges that one might face, right? When you're building healthy data pipelines, particularly across various stages, ingestion, preparation, whatnot. What are some of the challenges? If you could just highlight like top 1 or 2 challenges panelists taking turns when doing this building the data pipelines, that'll be great.
Mm-hmm.
I can chime in with one probably lots of people have experienced is getting the online features and offline features to agree. So oftentimes we'll be training our models with stored data, and then when it actually goes into production, we're serving it at prediction runtime. We have to recode the features coming in real time, and there'll be disagreements between what we train the model with and what the model actually receives at prediction time. And just those discrepancies, even 1 to 2% or up to 5%, can totally throw off, especially, for example, maybe you're training a fraud model. It's in those anomalies where the real predictive juice comes. And that's been a real pain point. And it's difficult, right? Because in your offline analytics data storage, you want your data to be cleaned up, sanitized, deduplicated, complete. And so there's a layer of processing it goes through. But if you then put that into your model and train with that, but then expose it to the raw, messy data at runtime, you're going to get something very different than you expected. So that's one thing we've been navigating with, and is expensive both manually and from a cost-wise to duplicate those features for training.
Thank you. 𝗁𝗲, do you want to go next?
Sure. Overstock challenges, I would say, is maybe it's less of technology, more of a cultural challenge. I think we're trying to change the culture, engineering culture here, where they treat data as a first-class citizen. The platform team itself is trying to provide these data producers with tools to produce quality data right out of the gate. Right, so we want our data producers to attribute correctly, document it, version their data, have proper lineage. They should be able to build access to data both for offline and online access. Right, I think data quality should be responsibility of the data engineering teams rather than it should be an organizational responsibility rather than just the data engineering team's responsibility.
Awesome. Abhijit?
Similar to what Vidhu said, like we also consider data as the kind of the core, kind of the asset of the company, as well as it's our like number one job to make sure as machine learning organization to like have high quality data. So we have to solve a whole bunch of data challenges, and including the one that Alok mentioned, like the difference between online offline calculations. That's like closing that parity gap between production system and our warehousing, where you build your models. I would say the one additional aspect of ours is that we also have to make sure we have the proper governance and access, and as a financial company, you cannot just use any kind of data for building any kind of models. So there has to be a data governance and control kind of you can think of it as a mesh on top of everything that we just talked about, that controls what type of data goes into what kind of models. So we had to build a lot of that into our existing systems as an add-on. And of course, having 100% of all our systems producing and consuming data on the cloud, just cloud data platform management becomes like a heavy, kind of like part of that challenge.
Awesome. Abhijit, thank you for bringing that up. I was like, hey, what, nobody has spoken about governance yet. Thank you. On that note, question to you all. What would be your tips, particularly like, I'm more interested in the bias detection, model performance detection, model drift aspects. What would be the tips that you would provide to the data scientists with respect to the feedback loop? One, do you have that in practice right now? If so, like, what are the best practices or tips that you would share in terms of detecting any bias or any model drift, performance drift, and then going back to the dashboard or going back to the whiteboard?
I can tell you from a financial company perspective, every materially important model, meaning that models that we run on our platforms that have a material impact on the company, like if there is a model that's making decision and it's not making the right decision for whether it's a data drift or model error, we might have a huge liability on our credit portfolio or balance sheet. For all of those types of use cases, we have inbuilt model monitoring in place. So as soon as you deploy a model, the model owner has to make sure there is monitoring in place, and that can measure, that can have a wide variety or type of monitoring, specific to the type of model that you are deploying. So that's, some of it is out of the box, like when you deploy a model through our deployment pipeline, it just starts automatically generating reports. Some of it has to be retrofitted on top of what we provide as a base monitoring stack for that specific type of model that they're deploying. So it requires, it requires more work to actually get that model deployed. But in either case, monitoring is an integral part of our platform. Like, you cannot actually deploy a model without checking that box in our deployment flow.
Awesome, thank you. Alok?
I would encourage practitioners to start with sort of an 80-20 solution. I know there's sometimes constraints on time and technology, and it's important to think about input feature drift and prediction drift and everything in between. What I would say is start with maybe looking at your distributions of predictions, especially on key cohorts or key cuts that you care about, and how that's changing day to day. Is there a step change? Or even month to month, sometimes these drifts can be very slow over time. And if you see something breaking on the prediction drift, then that's a good alert to go back and start to look at your inputs.
Thank you. And Vidhu?
Mm-hmm. I would say I would encourage practitioners to get familiar with their data, understand how it is sourced, how it's updated, what are its dimensions, get familiar with the workflows that your business counterparts work on, right? And pay attention to your data practices, version your data, attribute it, push to improve quality of data, not just for yourself, but organization-wide.
Awesome, thank you. I would like to bring up, there are some questions coming in from the live audience. Let me pick up some questions. For you, Alok, can you share some recent real-life ML use cases that either surprised you or delighted you?
I think one thing that's been never ceases to amaze me is how predictive demand can be for food delivery on the DoorDash platform. We've started to consume a lot more external information on weather events, sort of concerts and sports events happening, time of day, geos, and that really is very predictive on where we expect to see more demand, and therefore where we should expect to try to mobilize more dashers to deliver food, and recommend to merchants you may want to prepare for increased demand here. I think that's been very exciting, and again just speaks to, we all talk about ML, but really the power of data, the power comes from the data, and the more data you can get, the more predictive data you can get, the more cool and interesting things you can do.
Thank you. And okay, and back to all the panelists, there's something more of a futuristic, or your take on the future. What do you see as the greatest area of improvement in this? Is it technology? Is it people? Is it process? Or is it a combination? Can you talk a little bit more about that from your perspective?
My mind.
Go ahead.
Greatest improvement or area of improvement when it comes to the convergence of DataOps and MLOps.
Mm-hmm.
Vidhu, do you want to go take a stab at it?
Sure. In my opinion, I think it's process and people, right? Companies, engineering teams will become more data-centric. Teams will need to care about the data that they generate. The processes need to be automated. We need to make it easy to iterate in developing models with minimal overhead time. Right? I think that will provide the most productivity.
I'm sorry, I want to ask you real quick before the other panelists answer. But when you talk about this process, do you see it more about, is it technology driven, or what do you see from the technology to enable that kind of a process change, culture change? Do you have any comments on that? Yeah.
Sure. Process change, it is technology driven, I would say. Like a good end-to-end holistic ML platform, I think, will be a huge win. It kind of helps minimize the differences in technologies that data scientists work with as they move from, say, non-production environments to production. Right? We want to kind of keep it consistent throughout. That will ensure that it's a standard process end to end.
Thank you. Alok, do you want to take? How do you respond to the greatest improvement that you're seeing in the future?
For me, I think it would be part of process, but more I put the area on the people. I think there's a lot to do on education and culture. That MLOps is not about building a model, putting it into the world, and then sitting back and watching the good times roll. It's really an engineering system, and just like elsewhere in engineering, you have to really work hard at the reliability, the velocity, the scalability, on calls, etc. And it really has to be treated as sort of a first-class engineering system with handshakes, microservices, checkpoints, unit tests, etc. And for me, that's about education and people.
Awesome, thank you. And Abhijit?
For me also, it's the people. And we have 100 million customers. They are very broadly representative of the country. We have to build diverse teams, not just in terms of like education, their experience, how like we work with like product data science, legal, risk management. How do you get everybody to kind of understand the implications of what features, what data need to be used, what ML techniques? So it comes down to education and just create diverse teams to be able to do the kind of work, the impact we want to drive.
Awesome, thank you. So you all agree that it's the people side that's where there's a greatest need for improvement. I totally agree with you on that. Even the technology is complex, it's relatively the easier side of making changes. The people and process is going to be hard. Thank you. So on the other note, like all of you agreed upon data preparation challenges and whatnot. Do you see an increasing role of human in the loop or that changing, particularly around deployment, automation, or even data creation, the synthetic data, for example? What are your thoughts on that? Who wants to go first? Vidhu, do you want to go first?
Sure. I do see a role for human in the loop. I don't think it's ever going to go away. It's going to depend also on the area that the models are being built for, right? For example, high-risk areas such as healthcare, manufacturing, they'll always need human in the loop. Another area where I think human in the loop is important is where data sets are small, right? So you need to be able to kind of fill in those gaps. I think those are the areas.
Thank you. Alok?
Yeah, I agree. In a past life, I used to work in high-frequency trading. There'd always be someone on the buzzer to stop the systems if something weird starts to happen. But at DoorDash, we've been excited about a lot of our data enrichment and tagging work, where we very much use the models to tell us where they need more data to train, being able to tag an item as pizza or an item as a burger. And then we go and collect that, feed it back in. And it's very much becoming a blurred line between where the model ends and the human input starts. And that's actually a really nice workflow that I don't see going away too soon.
Awesome. Thank you. We are over time. Thank you for your time, panelists. It was wonderful. Thank you for sharing your expertise. Thank you all. And thank you, audience, for tuning in. Have a great rest of the day.
Thank you.
Thank you.